Alright, this is your Chapter 2 review. All of these questions should look familiar because I believe you've seen most all of them before. So like the first one, we're writing the slope-intercept form of the equation. Remember, the slope-intercept form is y equals mx plus b. And so this one is pretty easy. Like we can see here that our y-intercept is 1. Right, we know that's the point 0 and 1. And then we just want to figure out what our rise and run are for our slope. So if I go up 3 and right 2, go up 3 and right 2, so both of those are positive numbers, which means my slope is going to be a positive 3 over a positive 2. So my answer for number 1 is y equals 3 halves x plus 1. In that slope-intercept form, I believe we did that exact one last week. Number 2, we're writing an equation in slope-intercept form. Again, y equals mx plus b is what my final answer would need to be in. But different this time, however, is the fact that they give us 2 points. And so I'm going to have to either use the first method by plugging in the slope and x and y and solving for b, or use point slope form. It really doesn't matter to me as long as you show your work. You will need, regardless of the method, you will need the slope formula. The slope formula is the y2 minus y1 over x2 minus x1. I do have to do that first. Remember, it doesn't matter which point you actually let be the 2's and 1's. That just means it's my first one and my second one and whatnot. So the slope for this one is going to be negative 1 minus 5 over 7 minus 2, change in your y values over your change in your x values. So in the numerator, I get negative 6, and the denominator, I get 5. Again, we did this one last week, so this should feel familiar. I'm going to use point slope form, simply because it's straightforward. So y minus y1 equals m times x minus x1 was point slope form. So we're going to use that with our numbers, and we're going to simplify it so it's in slope-intercept form. So I'm just going to go ahead and use 2 and 5 because I want to. So y minus 5 equals negative 6 fifths, and then x minus 2. So since I want it to be in slope-intercept form, because that's what it asks for, make sure and read your directions, I am going to have to use the distributive property and whatnot. So using the distributive property, I do get y minus 5 is negative 6 fifths x plus 12 fifths. Yeah, okay. And then I do need to add 5 to both sides to isolate the y. So I get y equals 6 fifths x, negative 6 fifths x, sorry, don't forget that negative. And then 12 fifths plus 5, so like if you want to do that to the side or whatever, 12 fifths plus 5 is the same thing as 12 fifths plus 25 fifths, find out a common denominator, so that's going to be 37 fifths, which is not a nice y-intercept, but that is my solution for that one. So whenever you're given 2 points and asked for slope-intercept form, you have to use point slope form or the other method in order to get there. Number 3 is just asked to graph. This is again in slope-intercept form, so I know that 0 and negative 2 is my y-intercept. I said it, I didn't write it, so that point has to go here. We know that this slope is a negative 1. I want it to be a fraction, so I want to make it negative 1 over 1. That means I'm going to go rise over run, left and then right. So from this point, I'm going to go left and then right, which would put me right here. And of course, I'm going to do a few of them because this pen is not very user-friendly. I want my line to be fairly accurate. So negative 1 over 1. So that's number 3, graphing the equation. That one's pretty simple. All you have to know how to do is count on that one. And then the last one with slope-intercept form is probably the easiest one on the test. And so just ask, hey, what's the slope, what's the y-intercept? And I give it to you in the slope-intercept form. So this is an identification problem. I know that the y-intercept is 4/3, so to write it correctly, I know I'm going to say that my y-intercept is the point 0 and 4/3. And then my slope I know is the coefficient of x, so in this case it would be 8/5. That is all you have to do on that problem. Please do not overthink it. Nothing to work out. It's just, again, an identification problem. And then we move on. Like this is point slope form. We did a couple of these on the day that we were graphing that zombie activity. And so I'm just going to pull some stuff out. Again, remember point slope form is y minus y1 is equal to m times x minus x1. And we talked about whenever you pull those numbers out, make sure you're using the correct signs. So here I know like this is the x1 value and this is the y1 value. But since there's a minus built into the formula, that means my point is actually a positive 3 and a negative 4. Okay, so that's going to be the first point that I graph. Positive 3 and negative 4 is right here. And then I can see my slope is a negative 1/5. And remember what we talked about that negative. It doesn't matter where it goes, but it can't go on both. I'm going to choose to put it on top so that I can go down 1 and right 5. Never mind, I changed my mind. I now see that that's going to be an issue on my graph. I can't go right 5 without running out of room. So I'm going to switch it up. And that's totally allowed. Again, the negative can go on the top or the bottom, which means I would go up 1, but then left 5. And that's going to give me the same line. And it actually fits on my graph. So I'm going to go up 1 and then left 5. So that would actually put me here, I believe. My lines are really faint. Yeah. So there, alright, pen, but except for, correct and things. There we go. This pen drawing tool is not that nice sometimes. So a perfect example of it's okay to move the negative to your advantage based on your graph. Again, if I had chosen to do the negative in the numerator, it would have worked. I just would have went off my graph, and I really didn't want to do that. So that's why I chose to put the negative in the denominator. Number 6, again, pretty simple one. All you're doing is you're writing the equation, make sure and read the directions in point slope form. So I'm going to write it in that form that we just wrote at the top of the page. There's nothing to work out here, where I'm just making sure my numbers, that's an x in the right spot, and that's my n. So I'm going to do y. If I do a minus negative, I know that's positive 9. My slope is a negative 3/2. And then my x is negative 1. So again, that's going to be minus a negative or positive 1. Again, do not work this one out. There's nothing else to do. They asked me to leave it in the point slope form. So that's the answer to number 6. Number 7 and I believe number 8, yeah, were the special graphing ones where I have only an x or a y as a value. Just going to have to remember what we talked about. Is not a slanted line. It has only an x or a y value. So this particular one is going to be a horizontal line at y equals 2. Well, I know y equals 2 right there, because that's my y-axis, and that's 2. So I know that all of these points that lie on this horizontal line at 2 would have a y-coordinate of 2. So that's number 7. Number 8 is the opposite of that, right? My x is a negative 1. So on my x-axis, here's the value at negative 1. Which means that all of the points on this, it's hard for me to see, on this vertical line here that goes through negative 1, have an x value of negative 1. So vertical, horizontal, it's up to you to remember which one's which. Excuse me, number 9. We're going to write this in standard form using integers. Remember, standard form was ax plus by equals c. Where a, b, and c are not allowed to be fractions or decimals, right? We have to make them into integers. So I'm just rewriting the problem up here. So the first thing I'm going to do, and it really doesn't matter what order you go in as long as you do the steps, I'm going to move my x value to the left side so that it is on the same side as my y value. So all I'm really doing is just moving it, right? So that's negative 1/6 y. Excuse me, that's an x. That's an x. That's an x. Oh, it's late. Here we go. 1/6x plus y, there we go, equals 12. So I have my x and y values where they need to go. I just need to get rid of that 1/6. Now that's the only denominator in the entire problem, so obviously that would be the common denominator. I'm going to multiply every term times 6. Every term times 6. So negative 1 6 times 6 is negative 1. So that's going to be a negative x plus 6y equals, and then of course 12 times 6 is 72. So that's the answer for number 9. Number 9, you're just taking a slope-intercept form and writing it in standard form. So number 10, we're looking for the x and y intercepts here. We went over that in class. Some of you guys chose to graph that way when we were doing the activities earlier in the week. And so I'm going to do this one kind of right here. Let me change colors. So like if I want to find the x-intercept, remember what we're going to do is we're going to let that y value equal 0. Right? We know all x-intercepts have 0 as a y value. Well, if I let my y value equal 0, that means this term right here is going to go away. And all I have left is 5x equals 20. And I can solve that in my head really quick. 5x equals 20 is just 4, so that means my x-intercept is 4 and 0. To find my y-intercept, I'm going to do the same thing. But this time, I know that the x value is going to be 0, right? Everywhere on the y-axis, every point has a 0 for our x coordinate. So if I put 0 in for x, that term's going to go away because 5 times 0 is 0, right? That goes away. On this one, I don't have anything to solve. It's just straight up y equals 20. So we know that our y-intercept is 20. So we use that to graph a couple of times. Sometimes it's nice and easy. Sometimes it's not. These two obviously turned out really pretty. And that is number 10. Number 11, you're writing an equation. Again, make sure and read the directions in slope-intercept form for the line that is parallel to the given line and passes through the given point. Oh, decimals. Didn't realize that one decided to pop up. It's fine. It's fine. I know that the slope of this one is 9.3, right? That's in slope-intercept form itself. So that's the slope of this line. And since it's parallel, we know we're going to use the exact same slope. So I'm just going to take and put it in point slope form. So y minus 7.8 equals 9.3 times x minus 0.1. Again, using point slope form. Just happen to have nasty decimals. And I could kick myself in the foot. But it's the same thing. I just complain about decimals because they're not my favorite. I do have to use the distributive property, right? So I'm going to do that. So I get y minus 7.8 is equal to 9.3x. And then minus 0.1 when I multiply by 1. Okay, so I need to move it so it's going to be 0.93. And then I just need to add 7.8 to both sides. And I know I'm about out of room. Alright, so my final answer, let's see. I'm going to have to y equals 9.3x. And then I need to do 7.8 minus 9.3. I cannot do that in my head, so I'm going to come down in here and do it. 7.8 minus 0.93. Old school subtracted. I do not have a calculator handy. Excuse me. So that's going to be 7. Of course, that's going to be what? 8. So 6.87. So that's 6.87. Maybe I did all of my adding and subtracting right. I'm in a hurry. I apologize if I did anything wrong. You guys have met me before. Here we go. So that's number 11. And then number 12, this time we're doing the same thing, but different. Again, we're writing it in slope-intercept form. This time we want a perpendicular slope. And if you'll notice, obviously this equation happens to be in point slope form. So I know the slope of this line is negative 1/2. Because, again, that's point slope form, the number in front of the parentheses. But that's not the slope I want to use. Remember, perpendicular slopes are opposite reciprocals. So the slope that I want to use will be a positive 2/1 or a positive 2. And then, of course, my point is negative 5 and 1. Now, just like last time, I'm going to put that in point slope form and make it look as pretty as I can. So y minus 1 equals 2. And then x plus 5, because minus a negative. Again, using the distributive property, I get y minus 1 equals 2x plus 10. And then, of course, I'm going to have to add the 1 to both sides. So my answer is y equals 2x plus 11 is the equation that is perpendicular to the given equation and happens to pass through the point -5 and 1. The last three are, hey, are these two parallel, perpendicular, neither? I'm going to expect to see the slope on all of these. So if you just write the word, and we're not going to take it. Okay, I need to know that you know what the slope is. So like obviously the slope of this one is a -7/4, right? Super easy slope-intercept form. The slope of this one is -2. The slope of this one is a -7/6. Right, we can see the slopes of those super duper easy. It's the other ones that you're either going to have to change into slope-intercept form, or you can just use that shortcut that I showed you that said, hey, if it's in standard form, and all three of those are, all you have to do is a -a/b. And that's what I'm going to do. So like on this one, I get a -16 over -28 because it isn't -28. So if I reduce that, I know I can reduce both of those by a factor of 4, and two negatives, when you divide a negative by a negative, you do get a positive. So when I divide that by 4 and divide that by 4, then I can see the slope is 4/7. So obviously not parallel because they're not equal, but they are opposite reciprocals. So these two are perpendicular. That is the answer to number 13. So same thing with number 14. My slope here is going to be a negative. A already happens to be negative, so a -6/3. So a negative again is a positive. And then +6 divided by 3 is a +2. So that one is the same number. You both have 2, but one's negative and one's positive. So they're not the same, and they're also not reciprocals. So this would be a neither answer, and that can get kind of tricky. Again, to be parallel, they have to be exactly the same answer and not just the opposites. And then finally, the last one. Let's just check that one real quick. Again, the slope for this one is going to be -a, so a -21 all over a -18. So all of these negatives. So a negative is a positive divided by a negative is a negative, right? 3 negatives make a negative. Both of those are divisible by 3. So if I divide that by 3 and divide that by 3, I get exactly the same slope as my beginning slope. So those two are parallel to each other because they are exactly the same answer. And that is your chapter 2 review. I know I went a little fast, but you're more than welcome to stop, rewind, watch it as many times as you like. And all of these questions, again, we have seen before, so it should feel pretty comfortable. Be ready for your test tomorrow.